We spent a lot of time changing the equation, seeing how that transformed the function, and what the graph looked like afterwards. We should spend a little time doing the reverse. If we have a graph that's been transformed, what was the original parent function? What changes were made? And what is the equation of this new graph? So I think you can tell from its classic shape with a V that this was originally parent function y equals the absolute value of x. But that normally starts here at the origin and then spreads out. The vertex is no longer at the origin, the vertex is down here. So it got moved. It got moved left 5 and down 6. So the original, y equals the absolute value of x, it must be y equals the absolute value of something, subtract 6. The down 6 is going to be a minus 6 on the end. Well, the x's move 5 spaces to the right, but remember the x's compensate. I'm sorry, 5 spaces to the left. They compensate. So if the x's move to the left 5 spaces, that means that originally in here, this was x plus 5. So that would be hopefully the equation of our new function. We can check. We should always check. You can use either point. I'm going to check with this one. X equals negative 5, y equals negative 6. So put a negative 6 in for y, a negative 5 in for the x. And we have negative 6 equals the absolute value of 0 minus 6. Yes, that checks out. This is indeed the equation for that graph. On the next one, after all the time we spent on polynomials, this parent graph was y equals the cube on x. Now this is a positive cubic, but normally it takes this little twist here at the origin. It's taking its little twist at the point cross 2 up 1. So this moved to the right 2 and up 1. So this equation is going to be y equals something cubed plus 1. Remember the x's compensate, so if it moved 2 spaces to the right, this was in here, this would have been x subtract 2. We should check it. Pick one of these points, see if they work. So I'm going to pick the easy one here. X equals 1, y equals 0. So put a 0 in for y. X is 1 minus 2 and cube it, add 1. So 0 equals negative 1 cubed plus 1. 0 equals negative 1 plus 1. Sure does, that checks out. Got a couple more. This one might look a little unfamiliar because it's not in its original position, but most of you do recognize that the parent graph would have been y equals the square root of x. Except that also usually starts at the origin. And this one starts left 1 and down 2. So it looks like we take our original, it's going to be y equals the square root of somebody, Down 2 means minus 2 on the end. And because the x's do everything backwards, if this point is one space to the left, then this originally would have been x plus 1 under the radical. We should check it out. I'm going to check it with the easy point again. 0 for x, negative 1 for y. So negative 1 would be the square root of 1 subtract 2. Negative 1 equals 1 subtract 2. Yes, it does. So it checks. This one, you've known for a long time. Parent function here should have been y equals x squared. But it got flipped down. So it's going to be y equals negative x squared. And we should check it out. I don't want to use the 0 because that's kind of like cheating. If we put a 1 in for x, square it, take its opposite, do we get negative 2? No, we don't. If you put a 1 in for x and square it, take its opposite, we get negative 1, not negative 2. The graph didn't get moved down any, didn't get moved left or right any. So if it came out to a negative 2 there, it was probably multiplied by 2. This is going to be a vertical stretch factor. We should check this point. If we put negative 2 in for y and a 1 in for x squared, so that'd be negative 2 equals negative 2 times 1. Yes, it checks. So this would have been the equation of the transformed function. Likewise here, this is the equation of the transformed function. Would you please go try one problem?